Okay, welcome guys. This is chemistry hangout. I don't believe you have watched the last class where I did the laboratory preparation. So today I'll be talking about the predicted question for the 2024 Waec practical. I have done the titration in my last video, but let me just quickly complete the titration so we go to the question. So let me do the titration again. I think I'll just do that once so that I will not waste time. Okay, so this, let me refill this one first. Very important. Where's my chem menu for? Let me refill this. I've done the titration in my last video and I've explained a lot of things, but let me just do one again so that I will not just waste much time. The video is on the channel, you can watch it. It was even a live. Okay, so filled already. If you check it now, that's 0. Let me see if it's not more than, okay, it's a bit. Let me release a bit. Okay, I'm good to go. So let me, this is my iron sulfate. So I'll just do one. I hope that this thing is not leaking. Okay, let me just do one. I've done it before. Okay, good. I've taken you guys through all those steps before. Okay, so okay, then very important, if you have not forgotten, let me raise this. So our 2 molar H2SO4. So our 2 molar H2SO4. Let's quickly do that. 2 molar. This is my H2SO4. Okay. So let's go to 2 molar. Alright. I need to release a bit. Please be careful. It's 2 molar. Still more than. Okay, 2 molar now. That's 10 mil now. So okay. So let's start titrating. So I'll just titrate just once, then I'll move on. Then I've done this before, because I'll just quickly run it through. Just take your time. Go closer. I can still see the videos. So you just have to be careful, and that's why we are doing all these things practically here. You can do all this at your various centers, they are not difficult. That's why we are showing it practically. We are showing it practically. Let's go. It's remaining to change now by a drop. You can see. Gently. See that now? Can you see that now? Let's check again. Okay, this time around I'm having, let's zoom it. Okay, this is 18, I think. Okay, this is 18 now. This is 18.12. Okay, I'm having 18.3. You can see this is 18 now. This 17, this, you can see, is this 17? Let me see. Okay, this 16, sorry. Okay, this 17. Oh, this 17.5. This 18 now. Let me, so that you guys will see it. Can you see this now? Let me turn it like this. Good. So you can see this is 17. This 17.5. This is around 17.6, 17.7, 8, 9. You can see. You can see 18 here. Can you see that? Good. So, which means same value that I got. So let me quickly prepare my table so that we don't waste time here. So the burette readings now. The burette readings. Okay. So I will just have my rough Okay, burette readings in centimeter cube. So I can have my rough first and second. I can have second so that I don't waste time. Second in centimeter cube also. I want to believe this is clear. So my table, I'll cover my table. And from here, then my burette readings, this will be my final readings, okay? This will be my initial readings, okay? Then this will be my volume of A. That's the kernel for now in the burette used. Okay? So you can close this table here. Okay, understand? You can close this table here now. So don't forget our volume of B. You know, the iron sulfate now is the one we pipetted, which is the B. So don't forget we use 25.0 centimeter cube. So for my rough, since I've gotten same values, so I can have 18.00 here for my first and second. Since the last titration I did, I got 18. This one too, I got 18. So I can just take my rough a bit higher. Since I already know the value I want to use, so I can just say my rough is around this. Just an example. So my initial readings, definitely because I refilled. You will see that before I started titrating, my readings was here. So I can now have 18.30, 18.00, 18.00. I don't know if you're getting this, so this is my table. So the average volume now, average volume of A used. So since this is, I can just use this 2, abandon the rough. So I'll just say 18.00 plus 18.00 divided by 2. So my average volume of A used will be 18.00 centimeter. I want to believe this is clear. Now take note, this is a predicted question and I need to explain something here. Just take note of the question. I have seen questions where they wrote by dissolving this of iron granules, of iron tablets, of any iron, because I'm taking from predicted questions now. So can be iron granules, can be iron metal, can be, you know, they can just put, but the iron is important because what we prepare is iron sulfate. So it can be iron tablet, can be iron metal, can be iron tablet, can be iron granules, any. Just understand the question so that even if they are changing the values or they are changing the name, you can still do something. Okay, so from there, let's go now. The first question says, calculate concentration of B in mole per dmK. Question 1. Let's go back to B. B solution obtained. Let's just use that. Obtained by dissolving 1.3 gram of iron tablet in 250 centimeter cube. I've seen a question, different question, can be iron tablet, can be iron metal, can be iron granules, still same prototype. Okay, put A into the burette and pipette 20 or 25. Okay, that's that. The equation of reaction is given. Good. The next concentration of B in mole per dmK. Now listen to that. Concentration of B in mole per dmK. Now if you look at this, let's take note of this. 1.38 gram of iron tablet in 250, which means that in this solution, because this is a solution, it is not only iron tablet that is there. Because it's a solution, it means definitely if it's a solution, there is a liquid substance there. So it's not only iron that is there. So if I'm talking about these values now, these two values has to deal with the solution, which is the tablet solution now. I don't know if you're getting that. So 1.38 gram of iron tablet in 250 of the solution. That means that is the mass concentration in 250 of the tablet solution, not only tablet solution. But here now, when they ask you to calculate concentration of B, not the solution, but concentration of B. So take note that these two values are for the solution of the tablet solution. So anytime I need to take values for the tablet solution, I will consider these two. Do you get that now? So which means concentration of B mole per dmK. How do I calculate it? I can use this now. 1 now. I can use CAVA over CBVB equals to NA over NB. I don't know if this is clear. So what are we looking for now? Concentration of B. Do you get that? So concentration of A is our acid they are giving us. That will be 0.01 times our VA. That's the volume of acid, 18.00, over concentration of B, that's what we are looking for, times VB, that's 25, is already here, volume of base, okay, equals to number of moles of acid to base. Let's come to the equation of reaction. They have given us our A is this, MnO4, right? Our B is this. So what is the mole here? There's an invisible one here. So 1 to 5. Do you get that? So we have 1 to ratio 5. So from there, we have that, make CB the subject, you have that CB equals to 0.01 times 18.00 times 5 over 25 times 1. I don't know if you are getting that now. So our CB will now be, let me quickly use our calculator. That will be 0.01 times 18 times 5. That's giving us 0.9 divided 25. That's 0.036. 0.036 mole per dm. I want to believe this is clear, very clear. Let's move on. Concentration of B in gram per dm cube. Guys, see that we are finding concentration of B in mole per dm cube. What's concentration of B in gram per dm cube? If you look at this formula, if you are familiar with this channel, you will know this formula are formulas that we have used and used and used. Do you see that? It's very important in titration. So we are looking for concentration in gram per dm cube, which is what? The mass concentration now. What is the mole concentration? We have gotten it. Molar mass, don't forget, we are talking about concentration of B, which is iron itself, and it is given already here. Can you see? Can you see? They did not give you the molar mass of the solution. They gave you only molar mass of what? Iron. Do you see that now? So, which means that we are now looking for mass. So, Roman figure 2 will be the mass concentration is equal to mole times molar mass. Some people will write it as mass concentration in gram per dm cube equal to mole concentration in mole per dm cube gram per mole. You are still saying the same thing. So our mass is now going to be, what is our mole? 0.036 times molar mass of B. That's iron now. So they are giving us here. You can see they didn't give us, we are not talking about molar mass of the solution. B now. So that will be what? That will be 56. So the mass will be equal to 0.036 times 56. That's giving us 2.016. That's approximately 2.02 gram per dm cube. I want to believe this is clear, very clear. So now, number 3 now. They now said mass of Fe2 plus in 250 centimeter cube of B. Can you see now? What is B now? You know, B is talking about the solution now. So we need the mass of Fe2 plus in 250 centimeter cube of B. Now, come with me. We have already gotten the mass of B in gram per dm cube. What is the meaning of gram per dm cube? Meaning you have 2.02 gram of B in 1000 centimeter cube. That's the meaning now. Concentration of B, meaning you have 2.02 gram per dm cube, meaning you have 2.02 gram of this B in 1000 centimeter cube. I don't know if that is clear. So now the last time we should look for it in what? In 250. So I can say 1000 centimeter cube is equal to 2.02 gram. Do you see that now? So in 250 centimeter cube, according to the question, we have x. So we cross multiply, our x will be 250 times 2.02 over 1000. So our x becomes what? Let's see. 250 times 2.02 divide 1000. Sorry, let me. 250 times 2.02. Okay, that's 505 divide 1000. That's giving us 0.505. So let's say 0.51 gram. I don't know if that is clear. Very simple. We have gotten mass of B in this. So 2.2 gram of B, we have it in 1000. They said, what is now what we have in 250? The reason why they are giving us this ion is because immediately you dissolve the ion in a solution, it becomes an ion. Do you see that now? The ion tablet becomes an ion. That's why they are giving you Fe2 plus. It's just a way to confuse you, but understand this. Mass is this 2.02 gram in 1000, then 250. If they said mass of Fe2 in 500, it means that 2.02 gram in what? In 1500 will be X. If it is 750, that's how we get that. I want to believe that is clear. That's my duster. Sorry. Okay. My duster. Okay. So from there now, what is remaining? Percentage of Fe2 plus in the sample of the tablet solution now. You know, something like this, or in the tablet, you understand? So, or in the sample of the percentage of Fe2 in the sample of the tablet solution, just like that. So let me rub off this place so that you understand. You can see they now mention percentage of Fe2 plus in the sample of the tablet solution now. Okay, so how do we get that? How do we get that? Percentage, that's figure 4. Percentage of Fe2 plus in the solution, in the tablet solution, will be equal to the mass concentration, okay, of Fe2 plus over mass concentration of the tablet solution times what? 100 over 1. Very important. So now we have these two values. Mass concentration of Fe2 plus is here already. The mass concentration, we have gotten that 2.02. Now what is the mass concentration of the tablet solution? You can see now tablet solution. So we are coming to this place. From this equation that they give us, they told us that we have 1.38 gram of the iron tablet in 250. Is that not? In 250 centimeter cube. This is that now. Understood how I got this. 1.38. Because we are looking for the mass concentration of the tablet solution now. You get that now. We are looking for the concentration of the solution. And they told us 1.38 gram is in 250. So 1000 will be what will be X. So our X will be 1.38 times 1000 over 250. And that will give us what? Let's use our calculator. So from there, we have 1.38 times 1000 divide 250. That's giving me 5.52 gram. Do you get that now? So, you know, this is a prediction. That's why I'm saying it. The question can be iron, maybe metal. You understand? Iron, metal, but it still follow the same procedures. You are asked to calculate all these things, you still follow the same procedure. So understand the steps. So you are not taking this one now. Don't forget to have given the formula. So the percentage now will now be mass concentration of Fe2 plus. We have gotten that already from our table. Do you see that now? 2.02. So that will be 2.02 over mass concentration of the tablet solution. Do you see that now? You have gotten that 5.52. 10 times 100 over 1. So the percentage of Fe2 plus in the tablet solution will be what? This is our calculator now. So we have that 2.02 times 100 divide 5.52. And that's giving us 36.59. So let's just say 36.6%, and that's all. I want to believe this is clear. So that is that. That's what we are expecting, because they have given us this kind of question in GC. I've seen this kind of, this kind of where we titrated this and we were using this very particular formula. But don't forget this is a prediction. Don't forget this formula holds. You already know if you are asked to calculate concentration of B, you should know what they ask you to do. And in the question, they didn't really talk much on A. Let's say, for example, they now say you should calculate the mass concentration of A. You should know how to do that. Mass concentration of A, that's KMNO4 is the A. They are giving you the mole already. So that one will just be mass to be equal to mole times molar mass. You get that now? Mole times molar mass. So that would be mass. I'm talking about if they ask us, it's just predictions. We don't want to leave any stone unturned. So the mole will now be 0.01 times molar mass. You can see they have given us in the question. I wrote it before. If you check, I wrote something of 158 as the molar mass. So that will be 158. So the mass of A, if they ask us to calculate for A, probably they ask us, that will be 0.01 times 158. That will give us 1.58 gram per DMP. I want to believe this is clear. So I'm just, this is not part of the question. I'm just putting this. If they ask you to calculate concentration of A in gram per DMP, mole times molar mass, because they are giving you this. And let's say, for example, they gave us, if they are giving us this, they cannot ask us to calculate A in gram per DMP again. They will tell us to calculate it in mole per DMP. It's simple. If they ask us to calculate in mole per DMP, we know mole is mass over molar mass. They would have given us this 1.58 over the molar mass they have given us 158. You can see at the end of the day, you still arrive at 0.01 mole per. Just understand all these things. So if I'm giving this mole for A, they might ask me to calculate the mass. I'll get this. If I'm giving the mass, if I'm giving this, they will ask me to calculate what? To calculate the mole. Then I'll still say 1.58, which is the mass over molar mass. Very simple. And if they ask me to calculate B, you can see the formula here. The B, you can see formula here. They ask me to calculate the mass of B, I've gotten the mole times, because it's iron. But if it is this, maybe it's this now, you have to calculate 56 plus 35.5 times. You understand all those things. But now, we are talking about iron specifically here. That's why we are using 56. If it is the compound of iron, you have to calculate the relative molecular. Just understand this prototype, and I tell you, the predictions will, at least God has been helping us on the channel to be coming up with at least 60% correct prediction. So this is how I feel they might try to twist it. So understand it, sit with this. In fact, if you want to know, maybe you are good at it, you can decide to change the values yourself and resolve yourself to be sure that you now understand. So instead of you to put 0.01 here, you can put 0.02 or 0.03. Do you get that? Instead of you to put 1.3 here, you can just put 2.4 in 250. Do you understand? Just try to change the face of the question, but all these things still remain the same. The values can change. Do you get that now? So that is that for titration for this year. I love you guys. If you have not subscribed to this channel, kindly subscribe to the channel and turn on the notification bell so that when we upload educative and informative videos like this, you are going to be notified. To all my students, to all students all over the place that are writing Waec, I wish you success. I wish you good luck. To every teacher out there that is striving to give students the best, to lead them to success, God bless you and God will reward us. This is Chemistry Hangout. We want to make things easier for us. We want to make things, we want it not to stress us. That's why you see we do the practical, we do the theory. Just try to improve our confidence. And I'm sure that at the end of the exam, we're going to come back joyfully to thank God and, appreciate the work we are doing here. So very, very important. I love you guys. Stay chemically active. This is Chemistry Hangout. Wish you success. Bye.